What we did on Friday is we looked at, we did like the integral of x to the n dx. What's the general formula? How do you do the antiderivative? N plus 1, right? X to the n plus 1 over n plus 1 plus c. Your goal is to make every integral you get look like that, okay? Except because we're doing U-substitution, but you can use any variable you want, it will look like this. Oh, du is u to the n plus 1 over n plus 1 plus c. That is your goal. Even when you get to higher order derivatives, a lot of them boil down to this. It's just how do you get them to look like that? That's the trick, or the art form, as he would call it. So we're just going to go through a bunch of examples here. Well, actually, I'll make that 3. If I gave you this, well, let's just talk about this first, okay? So x squared plus 1 times 2x dx. I want to know the antiderivative of that. What would you do to solve this? Okay, you can do that. Because this only has a power of 1, right? If it has a power of 1, I would just dump it in like that. It turns into the integral of 2x cubed plus 2x. And now what's the antiderivative of that? Well, what's the rule? We just saw it right here. Add 1 to the exponent, divide by that new exponent. So you get 2x to the 4, divide by 4, plus 2x squared, divide by 2, tack on a plus c. You can simplify them to get you can do it, but why would you? Yes, so that's what I'm going to show you right now. Okay? You don't have, I mean, you can, but it'll be more work. This is pretty straightforward. If you can make it a polynomial, make it a polynomial. Polynomials are easy to integrate. All right? If the power there is 1, dump it in. If, we'll do the exact same question. So x squared plus 1, 2x, but I'm going to make it to the power of 4. Now, you cannot dump the 2x in. Why not? Because, yeah, it means x squared plus 1 times x squared plus 1 times x squared plus 1 times x squared plus 1. So now you would do U-substitution. Okay? So what is U going to be? X squared plus 1. 99% of the time, U is what is inside the brackets to the higher power. Okay? So we go U equals x squared plus 1. Then we do our derivative. Du dx is equal to 2x. What do I do now? You want to get rid of, so essentially we have This is gone, right? This is now u. But I have all of this bit to get rid of. So what do? I don't solve for dx. Solve for du, right? I multiply the dx up here, so I get I do that. Because, see this here? That matches this, right? So now, instead of this being 2x dx, what is that? It's just du. So, hey, sorry. Yes. Well, these are the most simple ones. There's going to be harder ones, but essentially it'll work out so that you get u and du. Okay? So you mean go like this? Du over 2x equals dx? Okay, you can do it that way if you want. I don't do it that way. I just go, I solve for du. I solve to make this bit disappear, because what you want is you want an integral, because this integral now is the integral of u du. You want an integral that only has u's in it. X's are all gone. Yes, to the power 4. Thank you. But you want an integral where all the x's are gone. We've subbed them out. Okay? I know. So it doesn't matter which way you do it. I think it's easier just to take this, multiply it up. Oh, I got 2x dx. 2x dx is du. I'm done. Okay? Do you want me to make it more complicated? No. So now I can solve this integral. U to the 4 du. What do I do? Add 1 to it, divide by the new exponent. So it becomes u to the 5th over 5 plus c. What's u? We're not done. Yeah, you got to sub back in your x squared plus 1. So it becomes x squared plus 1 to the 5th power over 5 plus c. And you're done. Once you integrate it, the du goes away because it's the antiderivative, right? Yes, exactly. Less. Yes, these ones you can solve without doing substitution, but there's going to be ones that are way harder that you can't. Yeah. Okay. Number 4. Is that clear though? You just want to solve to get rid of everything. Everything here is in x's. You want everything to be u's. Okay? All right. So let's do okay. X squared times 6 minus x cubed to the 5th power. What's your substitution going to be? Yeah, what's in the brackets? And the easy way is, what you should do actually, and this will be pay off later on, when we get into more complex ones like logs and stuff. I know, just when you look at this is what you want to do in your head before you do anything. When you look at this, because you know you're going to have to do the derivative when you sub it out, right? So look at the powers. What's the exponent here? What happens when you do a derivative? What happens to the exponent? It goes down by 1, right? So that's what you want to sub out. Because if you take the derivative of that, it's going to become an x squared. Sorry? Well, you have to do the substitution, right? And stuff will, and you'll get rid of all these x's and dx's and turn them into u's and du's. That's the whole point here. Okay? And when they get more complicated, being able to look at it quickly and go, if I do the derivative of that, I get this. So that's going to be my substitution. All right? For the level you're going to be at, if it doesn't work out like pretty quickly, you don't like do the derivative and you're like, oh, that makes sense. You're probably doing something wrong. Okay? But it's an easy fix. You just sub out the other thing. Right? If you subbed in for this and it went crazy, or say you subbed in for this, let's just do it. Don't write this down, just watch. If you subbed in for x squared, you're going to go u is equal to x squared, du is 2x, so I get du is equal to 2x dx. Does that look like it's anywhere in there? No, it doesn't work out. So you know you did something wrong. So all you do is you sub out the other thing. Just erase it. Sorry, what? Yeah. No, I'll show you one. There's this, like, obviously these are the most simple ones because we just started, right? They do get more complex. So there's other tricks you have to learn, but we'll get to those ones, okay? But for now, they're going to be pretty straightforward. So we're going to go u is equal to 6 minus x cubed. Du over dx is negative 3x squared. So what are we doing? What do I need to get rid of? This is what you have to ask yourself. Here's u. I need to get rid of this and that. Is there an x squared dx in there? In this du over dx? Yes. If I multiply the dx up there, I get that. But what's the problem with this and what I have in there? It's negative 3, right? So what do I do to get rid of the negative 3? Divide it off. So if you just go so now you have x squared dx and x squared dx. So all this stuff that I've got circled in pink here turns into du over 3. So this integral now becomes integral of u to the 5th, and x squared dx is, du over negative 3. Are we okay? Where did I lose you? I'm trying to get rid of this. I've gotten rid of this, right? That's my u sub. Now I need to get rid of these two. Well, if I have this and I divide off the negative 3, that is the same as that, so I can sub that in. Yeah. So now I've got this integral. What can I pull out of the integral? Negative 1 over 3 gets pulled out. Now it's the integral of u to the 5th. What's that? Is u to the 6 over 6 plus c. And then sub back in what your u was. Was it 6 minus? 6 and 3 is 18. And there's your answer.
So the du just like goes away.
Once you integrate it, the du goes away. Because the du, this, if I was going to do the derivative of, say, this, right? I would do, say that's y. It would be like dy versus du is equal to, and then you get something, and then you multiply the du up, and that's what you get there, right? So that's why it goes away. When you do the antiderivative, the du goes away. All right. We okay so far? Okay. Let's do a trig one. That's a 5 inside. All right, what's your u going to be? 5x. Because what's the derivative of 5x? 5. Okay, so I do that. The derivative is equal to 5. What am I subbing out? Or what am I going to do now? du is equal to 5 dx. So there's my u. This and that become du. So now the integral is now the integral of cos of u du. What's the antiderivative of cosine? Plug back in your u. All right, one more? Well, we got lots more. Okay. Let's do I saw him do one of these. Let's make it simple for now. All right. Sine squared of x times cos of x is equal to dx. So you only have two choices here. You can be sine or you can be cosine. In your head, what do you do quickly? You ask yourself, the derivative of sine is cosine. Derivative of cosine is negative sine. For your level, the trig function with the higher exponent, or the exponent on it, well, I guess they're both got exponents, is what you're going to sub out. Okay? So u is going to be sine x. What's the derivative of sine? Cosine. So what do. So du is equal to we okay? All right, let's do one more and then I'll give you some practice. It's 4x cubed minus 9. So what do you want to sub out? Why? It's technically the brackets, but what's the derivative of 4x cubed minus 9? I actually don't care about the actual derivative. All I care about is what happens to this exponent. It'll turn into a 2, which will minus 9, right? Because that's a constant, so we don't have to worry. So that's going to be your u. So u equals that. Nope, because that's going to turn into a chain rule gong show. You can try it, but it'll get ugly fast. So du is, sorry, 12x squared. All right, drop down the 3. What do I do now? Multiply the dx up. Oops. Okay, you got some choices here now, because it doesn't match, does it? We've got this gone. That's my u. Oh, shite. There we go. All right. I need to deal with these two things. So, this has a 6 in front of it. So there's two choices. What can you do with a constant in an integral? You can take it out, right? So we don't even really have to think about this. And we just go, I need to get rid of this x squared dx. Can I do that? What do I have to do over there then? Divide by 12, right? You can divide out to 12. So du over 12 is equal to x squared dx. So now this integral becomes, so the 6 is still there. So I have on the outside 6. This is where your algebra has to be pretty good. That's what you get, which looks gross, right? How do you divide fractions? Flip the bottom one and multiply, right? So essentially, that's like over 1. So this becomes 6 times the integral. And I'm showing every step. You can do, if you're capable, do this. You can do this all in your head to simplify this down. What now? Do we want to integrate something where the variable is in the denominator? No. What do we do? You make the exponent negative. What do I do with the 6 and the 12? What does it reduce to? And now you can integrate it. How do you check your answers? How do you check your answers? You derive it and see if you get the original back, right? Okay. All right, so look at your choices for u. Quickly in your head, just go, if I do the derivative of that, it'll drop by 1 exponent and match that in terms of degree. That's what you want to sub out. When you do, solve for u, sub it back in, integrate the simple antiderivative, and sub back in your u. Don't forget the plus c or you will lose a half mark. Yeah. Okay, hang on. Okay, I'll do it that way in a sec, okay? Page 301, 5 to 25, odd, please. Just like derivatives, you have to know this basic stuff to do the harder stuff, and it's the next 2 weeks is this kind of stuff. And all this week is this stuff. So I'm just going to pause my recording. I know, everybody's happy. So here's our first one. The integral of x minus 4 divided by the square root of x squared minus 8x plus 1. Well, let's just talk about it first. I'm going to give you some practice ones here. Maybe.
What's the next letter? Can we pick it? Does it have to be
something? Well, I don't think we'll get to that this class. I mean Math 100 this year because we're going to run out of time. So normally, yes, we would do multiple substitutions. Yeah. Okay, here we go, peoples. Now we look at this. What do you do in your head other than swear? You derive what you think should be u. So which do you think should be u? Bottom. If I take the derivative quickly with the bottom, what do I get? Okay, is that going to be substitutable? Like, is that going to work? Essentially, is what I'm asking you. It could if you take out a 2, right? But the main thing is we go from a quadratic in the denominator inside the square root to a linear in the top, right? So I know that the bottom has to be my u because I'm going to do the derivative of it. So u is equal to x squared minus 8x plus 8. So then du 2x minus 8. Multiply the dx up. And I get that. So I've gotten rid of the bottom, but I still got to deal with this x minus 4 dx. What can I do to this 2x minus 8 to get there? Yeah, factor out of 2 or divide by 2, right? So if I rewrite it as so now it works. So now this bit up top is du over 2. So now the integral becomes the integral of 1 over u to the power of a half times du over 2. Yeah, I did it quick. Sorry. Is everybody with me? Where did I lose you, Asmita? Because this is my u, and it's all in the denominator, and it's the square root. Square root is power of a half. Yeah. Okay. So we're all good?
Flipped it over to multiply. Oh.
All right.
Factor out 1/2 from u.
No, I just flipped this u to the 1/2 up to make it negative. And I took this 1/2 out from that. Yeah. All right. Now, add 1 to the exponent and divide by that number. A negative a half plus 1 is 1/2. Divide by a half. Is that? Is that okay? We're good? Any questions on that? Where'd this go? Where did it come from? Half. So 2 times a half is 1. Or flip the 1/2 up and you get 2 over 2. Either way. Are we good? All right. Oh. Now we jump. We're going from grade 4 calculus to grade 8 calculus. Jumping 4 grade levels. I'm just making these numbers up, people. C. Sorry? Is it?
Let's go two.
Let's go with 2. Let's do this one question, then we go for break. Okay. Okay. What do you do first when you get a question? No. That's always the answer. Sorry? So, no, you do though, right? You look at it quickly in your head, and you go, what's the derivative of 2x minus 1? 2. What's the derivative of x? 1. So it doesn't seem like anything matches. Like before when we did the derivative, like this, I would do the derivative of this, and I go, oh, I get 2x minus 8. Well, that's going to line up with this. This time it doesn't. So when you get something that looks like this, whatever is the inside function, sub that out. You know what I'm saying here? If it's something inside a square root or something inside a cube or to the power of 8 or whatever, that is your u. So our u here is 2x minus 1. Do your derivative, just like you normally do. So I get that, and I've got that. Okay? Is everybody with me? We're with me? Okay, so that means this here is u. This is du over 2. What's wrong with the integral? You still got this stupid x here. How do I get rid of it? You can't do an integral that has 2 different variables. Only if they're being added or subtracted, not if they're being multiplied. What can I do with this? What can I do with this? Yell it if you know the answer. Who said that? Solve for x. Use your U-substitution and solve for x, because then I can sub that out. So, yeah. So I get x is equal to u plus 1 over 2. And now that gets put in there. So now you have an integral with nothing but u's. But we got to rewrite it. We're going to have to do some algebra. So my integral now becomes, instead of x, I have u plus 1 over 2 times u to the power of a half times du over 2. Okay, what do we do? We got to clean this up before we do anything. So what about the 2 2's? What can I do with that? Multiply them and pull a quarter out, right? You can pull constants out, right? What do I do with this u to the 1/2? Grade 9, grade 10, whenever the hell you learn that, dump it back in. So what's u to the half times u? U to the 3 over 2 plus u to the 1/2 all to the du. If you're multiplying exponents, I multiply u to the 1/2 times u, which is u, this. What do you do with the exponents? You add them, right? So it's u to 3/2. So now I can integrate this. Right? This is easy. You just add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. Don't forget the 1/4. So leave the 1/4 out, put everything in brackets. What's 3/2 plus 1? Yeah. So you're dividing by 5/2, so you know you're going to flip the fraction, so it's actually 2/5 in front. Plus u to the 3/2 with a 2/3 in front. Plus c, if you're really... Sorry? Doesn't matter. What's 1/4 times c? No, just c. Cares. Doesn't matter. Because you can add the c's together, you just get 1 c. Because you solve for c when we're doing what are called definite integrals, which we'll do tomorrow. We sort of did, but now you're going to start solving for, well, you'll see tomorrow. You can multiply the 1/4 in, it'll just give you denominators of 20 and 12. So you can write and then you can reduce those denominators and put back in your u. What is u? 2x minus 1. Uh, 6 plus c. So that is the answer. 2x minus 1 to the 5/2 divided by 10 plus 2x minus 1 to the 3/2 divided by 6 plus c. As you can see, they're starting to get a little more complicated now. Okay? But again, you could always check your answer by doing the derivative and seeing if you get the original back. Although these ones, that's not going to be a super easy derivative because there's going to be a lot of algebra to simplify it. Go on break. I got 2 more examples to do. So go. Root x plus 1 times root 2 minus x times dx. First question, what would u be? Two minus x is u. What's inside the square root? Go. I'll freeze it. I'll do the Torsten freeze.
No, are you going to keep it recording for 5 minutes?
I'm going to do commentary. Julia has made the mistake right off the bat of the wrong substitution. Let's see where this goes.
X not equal to 2.
Yes.
Where the fuck does he go? I hate this. Like, how do I write it?
Okay, X equals negative. You just show us your work. I don't know what I'm doing.
Suffer, it builds character.
I agree with that. Off. Right at the beginning, I screwed it up too. Yeah, D is negative. That's not what I screwed up though.
That one's pretty good too.
I'll show you what I have so far. I haven't finished it yet. That's where I got to. So U is 2 minus X.
I got that too.
Du is equal to negative dx. So I divide off the negative. So negative du is equal to dx. There's that substitution. U is already that. Rewrite this to solve for x, which is 2 minus u. Here's the trick. That goes in for x. So you get 2 minus u plus the 1 that is still there. 2 plus 1 is 3. So I get 3 minus u. I can pull that negative out. That interval, dump that in, you get that. Now we got to integrate that. Did you? Okay, go. Keep going. Two plus 1.
I feel like he just.
I got minus. Oh. Where did the 2 minus? Because it was negative. So it's negative like that. Why'd you just pull it? Oh, so you can just get rid of it.
Wait, you did just that?
Oh. And then. Is it my girl?
Good thing you guys are discussing this because this is the bonus question on the test. Where'd you get lost?
Way behind, like I just figured out how you got 2 minus u plus 1 u to the power of half, and this is
These are all just substitutions, right? That's my 2 minus x is my u. And then I derive that to get negative du is equal to dx. So that blows that out. And then I have to get rid of this x. So I solve this, this for x. And then that goes in for x. So that's where the plus 1 is. Sorry? Yeah.
oh, it's like our lost equations, like when you put the h in place, they're all
Yeah, the only thing I forgot to do speed retro where you do that. That's what I
I was going from him.
Oh, smashing our table.
So on the other one,
Yeah, so you should
I didn't have one day
go ahead.